So alkalis, just like acids, alkalis can be also stronger alkalis and weaker alkalis. As I said, acids are stronger if they provide more hydrogen ion, they release more hydrogen ion, they dissociate completely, okay, provide ample amount of hydrogen ions. If they dissociate weak, reversible, weaker hydrogen ions concentration, weaker acids. Stronger alkalis like NaOH, KOH, both are known as caustic, because stronger alkalis like stronger acids are corrosive, they will burn the skin. Caustic, corrosive they are. This is caustic soda, this is caustic potash. And look at the one-way arrow. I mean, they completely dissociate into water and provide all the hydrogen hydroxyl ions they have in the concentration mentioned. 1 mole per dm cube, 1 mole per dm cube hydroxyl ion. 1 mole per dm cube here, 1 mole per dm cube hydroxyl ions. Completely ionizes. They have a pH range of 12 to 14, corrosive they are, used making for soaps and detergents and many cleaning agents, and large scale use they have in industries and textiles and leather industries for caustic actions and many textile functions, clothing, okay, stone wash and stuff. Weaker alkalis, huge uses like antacids. We can't use the strong alkali here, that will definitely create pores, spoils, okay, burn. Weaker alkalis in toothpaste, weaker alkalis in antacids. Weaker because look at the arrow, when they are added into water they breaks up and provide what? Less amount of hydroxyl ions because they dissociate partially, weakly, poor ionization, okay, stuck to the state of dynamic equilibrium, which is more favored to the left side. Lesser number of hydroxyl ions, that is an advantage because they are weaker, and weaker one has their own uses, okay. So alkalis have uses in soaps and detergents. Neutralizing acids, okay, acidity is a huge issue around the world. Stomach acidity, they are being neutralized by the antacids, okay. Plenty of medicines like they contain weaker alkalis like magnesium hydroxide, the milk of magnesia, Zentex, and zinc hydroxide, and so many others, okay. Soils, huge issue around the world. Excessive use of fertilizers, they make soil acidic, and when soils got acidic, we have the weaker alkali, weaker base, calcium oxide, because when it is added into soil, mixed with the soil, this powdered thing, calcium oxide, and you give water to the soil, somehow it reacts and turns to what? Calcium hydroxide. And this calcium hydroxide in the soil, of course, dissociate and provide the calcium ion, but the important thing is hydroxyl ions. So calcium oxide, the quick lime, the lime, reacts with water in the soil to produce slaked lime. When it reacts with water, slaked lime, and this slaked lime stays in the ionized form and provides the hydroxyl ions. And you know that hydroxyl ions are there, then soils H positive ions and hydroxyl ions from the alkali, the slaked lime turns to water. So this way acidity of the soil because of H positive ion is tackled well by the controlled amount of hydroxyl ion that are released by a weaker alkali, the calcium hydroxide. And calcium hydroxide is yielded from calcium oxide. Calcium oxide is lime, okay. You can get large amount of calcium oxide for this process because there is large amount of calcium carbonate around the world. Limestone, you heat it, it will provide calcium oxide and carbon dioxide on decomposition. This calcium oxide, the lime basically is added into soil, mixed with, or in the lakes to kill the acidity. So that is basically the alkalis and their uses, okay.